All right, so we looked at a cubic function and then a cube root function, right? And we saw that if we have a function f of x equals x cubed, then the inverse of that function, f inverse of x, would be the cube root of x, right? And that would work if I were to start out with y equals x cubed, and I said, okay, let's find the inverse, and we swap the x and the y, and then I solve for y. What I would do is I would take the cube root of both sides, correct? And so we know that a cube root cancels out a cube, right? So we just get y by itself, and then we'd see the cube root of x, right? And so that's so what, like we talked about earlier, a cube root is the inverse of a cubic function, right? Cube root function is an inverse of a cubic function. And so, and we can basically replace this 3 with essentially any exponent, and we would solve it the same way, right? Like if I put a nth root here, right? If I put an nth power here, then in order to solve for that, I would take the nth root, right, of both sides. And so really we can we can have any kind of root here. It doesn't have to necessarily be a cube root. It could just be an nth root, square root, etc., right? Now with the odd function, remember that odd functions, the end behavior go up to the right, down to the left. And so with odd power functions, they work out well because they're one-to-one functions, right? Remember we talked about one-to-one. Let me draw this odd power function up here again. So with the odd power function, if, in other words, like if you just have that first leading coefficient term and you don't have any other, or you just have the leading term with no other terms, then you're not going to have these ups and downs and peaks and valleys and things like that, okay? So if you just have an odd power function, that's going to be a one-to-one function, because not only does it pass the vertical line test, but it also passes the horizontal line test, like we talked about when we talked about one-to-one functions, right? There are no horizontal lines that cross. So when you get the inverse and basically you swap, it's also going to pass the vertical line test, right? So that's why it has to pass the horizontal and vertical line test, because when you swap it, it needs to pass the vertical line test for it to be a function. All right. So odd power functions are one-to-one, and so therefore you can find the inverse of those, right? You can always find the inverse of all of those. Now it's a little different when we're talking about even functions, right? For example, the one that we worked with for a whole chapter was quadratics, right? So if I have a parabola here, then if I were to find the inverse of that, if I swap the x's and the y's, what would happen is I would end up with something like this, right? Okay. And that is not a function because it doesn't pass the vertical line test, right? So when we talk about our radical functions, square roots and even power roots are problems because by nature they go either up on both sides, right? Or at least by nature the even power functions, we know the end behavior, they go up on both sides or they go down on both sides, right? And so either way, you're going to have that situation where they're not going to pass the horizontal line test. And so when you flip them, they will not pass the vertical line test. So this is not a function as it is, right? However, we still can do the same algebra, right? If I change this n to a square, it would still be the same, right? Like if I had x squared here, I could still swap my x and y, and then I could take the square root of both sides. Square root and square cancel out, and so I get y equals the square root of x, right? The difference is we usually put a plus or minus here. And that plus or minus, the plus would give us this side of the graph, and the minus would give us this side of the graph. So all we have to do is just not include the plus or minus. Okay, so if we leave out the plus or minus here, then all we get is that top side of the graph. And so that's what a square root function is. So it is kind of an inverse of a parabola, but it's not the complete picture, right? You just get one part of the parabola. So you just get, when you have a square root function, you just get this one side of the parabola. Okay, so it's kind of a half a parabola on its side. So it still has that vertex feature, and it still has that sideways exponential growth. So it grows, or excuse me, not exponential growth, but it still has that rapid increase when you square a number, right? But it doesn't happen on the bottom side. It's not reflected. It's not symmetrical. Okay. All right. So let's see some square root functions.